Hello and welcome to Disseminate, the podcast bringing you overviews of the latest computer science research. I'm your host, Jack Wardby. We are recording today from ACM Sigmod Pods in Philadelphia, and I'm delighted to say I'm joined by Felix Campbell, who will be talking about his paper, Efficient Answering of Historical What-If Questions. Felix is a student at the Illinois Institute of Technology, and in the fall he will be joining Ben-Gurion University to start his PhD. He is interested in data provenance and query optimization methods. Felix, thank you for joining the show.
Yeah, of course. Thanks for having me.
Can you start off by explaining to our listeners what are historical what-if questions?
Sure. So a historical what-if query is we want to allow users to sort of be able to leverage the history of their database. Typically, there's actually a lot of interesting information that we can actually sort of exploit to sort of reason about our data a little bit better. So namely, historical what-if queries allow users to sort of make some sort of hypothetical scenarios that they might want to see how it would have played out with the rest of their database. So the canonical example that we use is in like an e-commerce scenario. You might have a shipping policy that was in the database that reduced the shipping fee to zero for orders of greater than $50. And so if you as a data scientist or analyst decided, we want to see what would have happened if we had set this threshold to $60 instead, we now provide a framework to not only answer this query, but also efficiently to more effectively allow data scientists to sort of test these interventions.
Fantastic. So what's the naive approach to answering these types of questions?
Sure. So naively, right, the structure of the query is such that we want to know the difference between the original database and this hypothetical database. So naively, in order to do that, right, we have our original database. This already exists. It's current. It's the truth, ground truth, so to speak. And so we need to create a copy of the database prior to the transactional history. So we use a time travel feature that's supported by many database management systems in order to achieve that. So after copying, then we apply the set of modifications to the history, which we then evaluate over the database, and then we simply just take the symmetric difference, right? So that's anything that's exclusively in the original ground truth database, or anything that's exclusively in the hypothetical database, and it's annotated to let you know which is coming from where.
Okay, fantastic. So what are the problems with this naive approach, and why is your solution better?
Sure, of course. So, the key part here is there's a lot of overhead in the naive approach to the problem, right? Namely, copying the entire database can be a little bit impractical with larger relations, especially if this is something that you want to evaluate a few times, right? So if you you change the threshold to $60 from our earlier example, maybe you want to try 65 or 70 or 45, but in this case you'd have to be copying your large relation for each invocation historically. Right. So on top of that, actually evaluating these transactional histories, again, over the database can be problematic as you have the overhead that would occur from actually executing these queries with side effects, right? So you actually are writing to disk, you're incurring the transactional processing overhead. So we would like to avoid this ideally if possible.
Cool. So with that in mind, can we go into a little bit more depth on your solution and talk about reenactment? How does that work?
Sure. So as I just mentioned, right, this big issue with copying, right, and it's the issue is that right, we can't reuse the copy after we've executed the history, right, because now we've made some side effects, right. So reenactment is a technique from our group at IIT prior that allows us to sort of rewrite a transactional history into a relational algebra tree consisting of selects, projects, and unions. So what this means is that actually we can basically what we call like replay or simulate a transactional history over a database without actually incurring any side effects, right? So you run the query, the reenactment query, right? And you get back a relation that is going to be the same thing as if you had executed the actual updates, inserts, and deletes as they were over the data.
So in your paper as well, you mentioned two additional techniques that can help in this sort of thing. So these are data slicing and programming slicing. Can you go into a little bit more depth about these as well and describe how they're useful?
Sure, of course. So data slicing and program slicing are kind of some techniques that we borrowed, at least particularly program slicing for the programming language community. But namely, what we seek to do in both is to kind of reduce the size of the computation. So now that we're doing reenactment, we're able to kind of piece apart those computations and reduce the amount of computation necessary. So in data slicing, intuitively, because of the structure of the problem, we concern ourselves with only tuples that might appear in the symmetric difference.
Okay. Yeah.
And so, knowing this, we kind of investigate this a little bit further to see, which tuples will necessarily have to be in the answer of the historical Whatif query, right? Which is the difference. So we investigated that, and we've come up with how to filter out the tuples prior to the reenactment to get rid of all of that extra data that we would have to process otherwise. And in the case of program slicing, it's kind of a bit of an analog to data slicing. In this case, we have a transactional history, and a lot of these transactions are actually irrelevant to computing the answer to the historical Whatif query, right? If we are concerning ourselves with modifying the shipping fee based on price, we don't have to care about changing a customer's country. That's a little bit not so precise of a statement, right? Because changing their country might affect a later shipping fee change. So, but in general, right? We just to demonstrate, like there's probably a decent amount of updates that you don't need to run again in order to answer the same question.
How does this solution then compare to other techniques in the literature, and what are the benefits of this compared to the other ones? Where does it improve on the pitfalls of those solutions?
Sure. So there's a few existing Whatif analysis systems. It's not a completely new idea, this Whatif analysis, hypothetical reasoning. I would say, in particular, our approach tries to leverage the transactional history of the database.
Right.
This presents a lot of information. There's a great talk today about a paper that is also a framework for hypothetical reasoning, but they don't really use the historical nature that we are able to actually leverage to sort of provide some predictions or some hypothetical answers. So in general, I would say the key to our approach, at least the problem is a little bit novel, right? Because we're looking at modifying this history and seeing how it would have been different. Yeah. And then the technique is novel in that there's been data slicing and program slicing done before in literature, even with respect to databases, but some of the more key technical aspects are, I would say, pretty novel.
Following on from that, are there any commercial database systems at the moment that provide anything like this in their current offerings?
So I think there's a number of commercial database systems that definitely provide the groundwork. I think the key things that we require for this is audit logging, right? So we actually need to have a transactional history before we do anything. So audit logging is key. But additionally, time travel, right? We need to know what was the state of the database prior to the history that we're trying to investigate, hypothetically. But in terms of out-of-the-box functionality, it doesn't really quite exist. Originally, this paper kind of referred to our system as a middleware for answering historical Whatif queries. And this kind of nomenclature pops up as a historic history. But yeah, so to our knowledge, it's definitely not an out-of-the-box. We actually have a slight extension to SQL to facilitate the Whatif queries.
How did you go about evaluating your solution? What sort of benchmarks did you use? Mm-hmm. What were the results? Give us some numbers and say how good
Sure.
this is.
So we were going to evaluate this, so we used a couple of data sets, some standardized benchmarks and some sort of real-world data. The challenge with this is obviously it's hard to measure some sort of ground truth, right? This is hypothetical reason. We're doing A/B testing without the B, right? There's not really. It can be hard to, and that's definitely a challenge that I don't know how much I should reference this other talk, but
go for it.
Of course,
yeah,
right,
yeah.
right. That's sort of an issue they had too, right?
Yeah.
Is they need to input this causal graph because they don't know. It's a hard problem.
Yeah.
It's something for someone to sort of, analyze that just with domain expertise. And so, but yeah, so we used some couple standard benchmarks. TPC-C specifically is one of the such benchmark that's used for pretty standard like query answering. Also the Yahoo Cloud Services benchmark. But also we used a taxi trips database from the city of Chicago.
Okay.
They have like an open data portal. And so the workloads that we used for at least the standardized benchmarks, they specify some like workloads, right? So they specify some updates, some inserts, some deletes. And so this is, we took these workloads, we made some hypothetical modifications ourselves, and try to understand how, different parameters affect the runtime.
What sort of parameters are we talking here? What
Sure.
are the knobs we can turn here?
Yeah, exactly. So there's quite a few knobs that we can turn. There's a lot of you can really dial it in. But in particular, right, the key thing that we've identified is, it's on its face, it's pretty obvious. But right, the two key things I would say are in terms of the speed up you'll get. Is the percentage dependent updates. So we term a dependent update as an update that we can't eliminate from the reenactment. And so, right, if everything is dependent on everything, right, you're not going to be able to benefit. And the same thing with the data, right, the data slicing as well, right? Yeah. So if every dependent update is modifying all the data, it's like you're not going to be able to get rid of anything from your processing. So those are the two things. So typically in like a real world scenario, right, you usually have updates that like make sort of certain like partitions or cuts. So if you're only modifying, for example, customers in the UK, or customers in the US, right, you're able to sort of isolate that as compared to modifying every single customer. The main difference in running time as well is obviously we scale in the size of the transactional history, right? So the data size doesn't matter with regards to program slicing, which is nice. Some other previous approaches that kind of don't do it exactly the same for the same problem, but do kind of a similar program slicing are linear in the size of the data. So it's not good, right? You have more data, it's going to take longer. It's something we would like to avoid. But in general, the results are against the naive method to our method, we're usually an order of magnitude better. Typically, our reenactment approach with all of our optimizations enabled is usually to win out over reenactment alone or either optimization alone. And there's some cases where this isn't necessarily true.
Yeah, what are those cases?
Sure. So as I mentioned, we have this case where we have, it's basically the extremes. So if we have an extremely high amount of tuples being modified or an extremely high amount of dependent updates, you're not going to be able to benefit. But there's an extreme in the data side where if you have very few tuples that are actually rows being modified by the updates that are dependent, it's going to be the case that it's actually, the program slicing is actually a pretty heavy algorithm, right? It's uses linear programming, and just to kind of like high level, it's definitely a hard problem, right? So there's some cases where because the amount of data that we're actually reenacting on is so small, right? It could be in the cases that we were testing maybe only, a couple to tens of tuples out of million. And in those cases, it's a lot simpler to just do those 10, 20 to 100 so tuples through the whole history rather than to try to do the program slicing routine, right, and try to cut away some of those updates. Sometimes it's just faster to just run it. There's definitely cases where, in particular with low selectivity, where the program slicing might not benefit. But we definitely see this. I mean, you don't even have to have that high of a percentage. Like even 10%, 25%, we start seeing some pretty significant improvement.
Fantastic. Where do you see this research being the most useful? Who can use this?
Sure. So in general, we kind of propose this as being just one tool in a hypothetical reasoning toolbox. We don't really, we would like to be able to help users in the future come up with hypothetical reasoning, but the question is right, who wants this? And that's a good question. And really, I think it's applicable to a lot of business scenarios, right, where we might have some, transactions, business transactions, or we might have some, really anything where you might say like, oh, we have a lot of, updates and inserts and deletes that kind of encode sort of what our business does in the database. And it's like, oh, we can totally use that to leverage that to help you make data-driven decisions based on sort of how your database behaved in the past, if that makes sense. Anyone who wants to, make better decisions, hopefully.
So I believe the code and the toolkit is publicly available. Where can people go and find that?
Yes. So it's on the database group at IIT's website,
Okay.
cs.iit.edu/tilde,
Yeah,
DB group.
We'll link the relevant
link it.
places in the show notes. Yeah.
But it's implemented on top of a system that we have kind of developed, particularly by the head of the group, Boris Glavik, but it's a system called GPROM. So that's like a middleware for kind of a lot of different provenance-aware tasks. So it's an extension on top of that. Okay. But in general, the algorithm can be found in the paper and can be certainly implemented elsewhere. With it's not the easiest to deal with, sure. But it's certainly tractable.
So, what's the most interesting lesson that you've learned while working on Whatif queries, and more generally in the area of data provenance?
Sure. It can be a little. It can be difficult to reason about. There's sometimes some unexpected surprises. Yeah. You'll think that you have like a condition that's good enough, right? And then you might find a counterexample. And so, obviously everything's an iterative approach, right? You come up with an idea, you test it, you look around. But that's definitely, right, there's a lot of, I think, nuance to this. For example, if we have some modified update that occurs later in the history, right, we have to consider that updates before are producing input to that as well. So we need to check the dependency between those later modified updates and updates that come prior. This isn't the case when there's only one modified update. Then we can just check them only going forward, right? We don't need to go backwards. Yeah. So I think definitely, it's there's a lot to reason about, and you just gotta, we're pretty certain now based on the proof. I say pretty certain, but we're certain. Let me be a little bit more confident when we say we're certain that we definitely kind of ironed out the semantics that all this has.
Great. So what do you have planned for the future?
Sure. So in general, like I said, this is just one tool in like a hypothetical reasoning toolbox, right? There's a lot of good work being done in this space right now. Be it from years ago, kind of introducing Whatif analysis, in systems like Caravan, but also like in the talk that we had just seen today, HyperR. Yeah. So there's a lot of interesting work to sort of continue to grow this toolbox. Yeah. Obviously, it's a hard problem to answer. But hopefully, either kind of directly continuing this line of work, perhaps by making the implementation more industry ready, a little bit more robust, a little bit more performant, or also increase the utility, right? So maybe, as we mentioned, sort of learning some relationships between the updates in the history. For example, if we delete a customer, right, we're going to need to delete their orders too, right? But it's currently possible that, right, it's that the framework is not smart, right? If you tell it to do it, it'll do it, but you might get results that aren't helpful. So we really would like to maybe in the future assist users in this hypothetical reasoning. And we can also apply this technique, the program slicing, the sort of underlying technical approach can be appropriated for some other interesting, sometimes more theoretical tasks. Yeah.
Well, that's fantastic. I think we'll leave it there. Thank you so much, Felix.
Awesome. Thank you so much for having me.
Yeah, if you're interested in knowing more about Felix's work, all the relevant links will be put into show notes. Do you have any social media accounts you'd like to shout out?
Just my website.
Okay, well, if you want to learn more, go look at Felix's website. Brilliant, and thank you for listening, and we will see you next time.